Aiden, she's walking in yellow tape.
I'm going to laugh like this from now on. Anyway, all right, so we're recording again, just saying. Okay, so we've got this cone that we are filling, the upside down cone, and when we are concerned about the rate of the height of the water, once it is at the 5 meter mark. So really, I'm going to come away from this drawing and just put this, or you could have just drawn that here, whichever. Each thing as far as time is concerned, okay? Now, I do not really want to do that with 3 variables. I want to do it with 2 variables, okay? So I'd like you to remember right before we went to lunch, we said that since the whole tank has a radius of 4 and a height of 8, then when the height is 5, the radius would be half of that, right? So tell me what is something I can say that, what does R equal?
1/2 H.
1/2 H, or H over 2. Does that make sense? Okay. So I'm actually going to put this in there, and I'll have 1/3 pi H over 2 squared times H. And we are about to take the derivative. So I'd like to kind of clean that up just a little bit. You don't have to, but it's a good idea. So what would this be? Pi over
4.
No. Pi over 12. H cubed. Right? Always want it in terms of... Now, by the way, I could have said H is 2 times R, right? And I could have turned this into an equation with just R in it. But I'm not interested in R, am I? I want to know how fast the water is rising, okay? Now, do what?
When did we just do that?
Say again.
How did we just do that part? Like next over 12.
1/3 times H squared over 4
Oh, okay.
would be, does that make sense? So, let's take the derivative. Well, the derivative of the volume would be dV dt. The rate of change of the volume with respect to time. Now, by the way, pi over 12 is just a number. It is not a variable, okay? So I don't have like a product rule going on here. This is just a constant. So 3 pi over 12 H squared times dH dt.
Oh, yeah. Wait.
H is but it's the x variable though, right? It's the independent.
Sure, this is the y and this is the x if you want. Sure.
Well,
But if you,
H is the x though.
but I am not taking the derivative with respect to one of those variables. I'm taking the derivative with respect to time. That's the difference. Thank you for asking. That was a great question.
If you want to simplify it, it's pi over 4h squared.
Great. Okay. So I have dv dt equals pi over 4h squared times dh dt. Okay. Whether you realize it or not, you have almost all of those values except for one.
dH/dt.
Right.
We do have, it ends up being dv over.
How fast is the water level rising? That right there, that is what we're trying to find. That is dH dt. That is the rate of change of the height with respect to time. That's what we're trying to find. Now, what is dV dt? It is the rate of change of volume, which says the tank is being filled with water at a rate of 2
cubic meters per minute.
And I'm going to basically,
You can just say cube.
I can just leave it as numbers. But actually, I always used to put in my units just to know if I've done the math correctly. Like,
Yeah, I like
seriously.
that too.
Yeah. So, what is it? Cubic meters per minute, right? Equals pi over 4 times 5 squared.
5 meters squared.
Oh, thank you. 5 meters squared times dH over dt. We don't know that. That is what we're trying to find.
dt s.
What?
If you wanted to write units, it would be dH in meters and then dt.
Well, all I'm going to do is get this by itself.
Yeah.
And that means it's this divided by this, right? So 2 meters cubed over minutes divided by pi over 4 and then 5 meters squared. So let's do the numbers and then let's deal with the units. Where's my, oh, there it is. Like I could put it in my pocket. Did everybody see me check my pockets for my calculator? Because that's not going to happen. 2 divided by, parentheses, pi divided by 4 times 5 squared.
20.
That's just 25 pi meters squared.
Yes. But over 4.
Yeah, over 4, yeah.
Yeah. And then 2 divided by all that. So I get about, did anybody else do it? Because I'm kind of nervous.
I got 8 over 25 times.
Okay, and 8 divided by
It's
25
like 0.102.
times
102, yeah.
Yeah.
pi. Okay. So 0.102. So 101.859.
Yeah.
Is that what y'all got? Okay.
If you look at the, oh yeah, if you look at the units,
It makes sense.
And if you look at the units, I have cubic meters on top. I have square meters on the bottom. So that's just going to be meters per minute. And that is a rate of change of the height. Yes. For a second there, I forgot what I was looking for. But so that, my friends, is how we find a rate of change or use a rate of change to find something else using related rates. It really revolves around this implicit differentiation. And the reason why we didn't just use dy dx or dx d something and not use the other one is because we're doing this whole thing with respect to time, meaning time is the bottom line here. It affects the radius, it affects the height, and therefore it affects the volume. So we're doing everything with respect to time.
Wait,
Isn't that kind of cool?
so going over this,
I think it's kind of cool.
is circumference the derivative of the area of the circle?
We're going to talk about that. Anyway,
Because
up above on your notes, I just want to give you some tips, and this is what we just did. So basically, if we are filling something, then that has to do with volume. And if you're talking about maybe a triangle or a angle of elevation changing, the angle of elevation of the sun will change throughout the day, So that's another pretty common rate of change problem. So whatever you're doing, either write the equation for volume if you're doing volume, or the area of a triangle, or the perimeter of something, or, write your base equation. That's what I did first. Now, I did this a little bit later. I interchanged 2 and 3, okay? But it is, at some point in time, you need to identify what you're given. In other words, the tank is being filled with water at a rate of 2 cubic meters per minute. That right there is dV dt. That is the change in volume over the change in time. Does that make sense? And this was our dH dt. So then we differentiate, okay? And that's what I did here. And then I cleaned it up a little bit because I knew I was going to plug stuff in. It really doesn't matter if you clean it up or not, as long as you plug stuff in correctly. Now, this is very important. Do not substitute values in until after you take the derivative implicitly. Okay? So you have to do step 3 before you do step 4. Okay? Absolutely. Otherwise, stuff gets lost in translation, because if you have a constant, that it might be important, but it would be lost when you take the derivative. So, that's, anyway. And then solve for what you're missing. Now, this is a little bit overloaded as far as space is concerned. So sometimes I do the unit stuff in my head, but believe me, just like Ace pointed out, hey, that's going to end up being M per minute. So it worked out. Always kind of keep that in the back of your head, and it keeps you from making mistakes. Or it did me, anyway. Especially in chemistry. Am I wrong about that? Or, yeah, right? Questions over this one? You just want to do another example to see it? Okay. So let's talk about, you drop something in water. What's going to happen? It makes the things. It makes the ripples. The ripples are going to be concentric circles around the spot where it was impacted first, anyway. Okay, so a stone is thrown into, oops, sorry, you can't see it. A stone is thrown into a pond, causing ripples in the form of concentric circles. I love that word, concentric. Concentric. And the circles are moving away from the point of impact at a rate of 20 centimeters per second. Will you all tell me, real quick, what is 20 centimeters per second represent?
dr over dt.
dr over dt is equal to 20 centimeters per second. Nice. Find the following when a circular ripple has a radius of 50 centimeters. And again, when the radius is 100 centimeters. Okay? So this first one, we're doing circumference. Well, what is the equation for circumference? 2 pi r. If you were going to say pi times d, that's fine, but we don't know anything about the diameter. We're given radius, so we're going to do 2 pi r. Does that make sense? Okay, we have our equation. We have defined the stuff we know. So now what is it time to do? Derivative. What is the derivative of c? dc dt.
2 pi dr over dt, right?
2 pi
dr over dt.
dr dt. Very nice. And like that was actually really nice, right? Because it's just like linear. And yes, we have
Of the circumference.
the rate of change of the circle's circumference is what we're trying to find. So I can just 2 times, pi. Why I put that in parentheses is beyond me. Times
20. Well, 20 centimeters per second.
20 centimeters per second, right?
Yeah, because
Okay.
we already defined dr over dt.
Yeah, we actually don't even need the radius.
Yeah, the radius does not matter.
The radius,
No, it does actually define that.
well, is we are doing circumference. Is circumference linear or is it
Circumference
area?
It's linear.
It's linear.
So it's not
So that makes sense.
because
So you need it for that.
So this is 40 pi centimeters per second. And sure, you can do 40.
25.6.
Cool. 125.6 centimeters per second. Although this was nice and pretty, the 40 pi business. So that was actually pretty easy. Again, circumference is linear. So that will be the easier one. And by the way, since it's linear, it is going to be changing, the circumference is going to be changing at 125.6 centimeters per second from the get-go until forever and ever, amen. Right? Well, I know. Other forces will act upon it, but yeah. But the area, that's a different story. Because what is the area of a circle? Pi r squared. So the derivative, so the rate of change of the area over time,
Is 2 pi r dr over dt.
dr dt. And so, by the way, what did you notice, Harry?
It's the yeah. The
That
circumference is
is the derivative of the area, isn't it? Isn't that cool?
Is that how you get
Integral? Is that the other way?
The other way would be the integral. Very good. The integral of the
2 pi r's?
circumference is the area. Yeah. Okay. So this will be 2 times pi times, wait, what do we plug in for r?
50 and then 100.
Very good. So I'm going to plug in 50, and then dr dt is 20, and that would be 1,000, 2,000. Would it be 2,000 pi?
2,000 pi and then 4,000 pi.
Okay. And then at when the radius is 100 centimeters, the area will be changing at a rate of 4,000 pi.
Centimeters per second.
Are you okay if I just leave pi there? Or do we need the decimal?
Yeah, I mean, it's the most accurate.
It's the most accurate. Very good. Now, what is the unit?
Seems squared per second.
Yes. And so if you're wondering if that works out, remember this 50 was centimeters and the 20 was centimeters per second. So that makes square centimeters per second, which is an area. So it kind of makes sense. Now, actually, on IB tests, the units are not a huge deal, actually. Like, very rarely would you be counted off a mark by not putting in the units.
If you put the wrong unit.
Right. So, yeah. So that's almost discouraging you from writing any units whatsoever. But, yeah. So, it's not a big deal unless it specifically says include your units. Now, if they say that, then I bet that the units would be critical to your next calculation, is the only reason they would do that. So that's been my experience anyway. Okay, so what did I do? I made an equation. I identified what I had. I took the derivative with respect to time, and then I just filled her in. And I did that for circumference, and I did it for area. Restroom, yes. Questions about this example? No? Are you sure? Oh, come on. They're not talking to me today. I'm just kidding.
Reasons why.
Well, let's get away from circles for a minute. You want to break from circles?
Let's go to 3D objects.
Wait,
Not a square.
triangle.
Okay, good. I mean, can you read? So when you read that a ladder stands upright against a vertical wall, do you automatically know right triangle? Now, you are assuming that that wall is straight up and down and that the floor is level. But to be honest with you, that's a safe assumption. By the way, the wall will keep going, but the ladder won't. Is he keeping you awake by poking you or something?
So let me just touch your eyeball. That's about okay.
Oh, wow. Let's don't and say we did. Okay. Be truthful. How often have you seen my tooth since I've had my mask off?
Twice.
You forgot about it? Fantastic.
How
Good.
often haven't I seen your
I've been looking up here.
And notice that my smile is all very reserved.
Actually, only once. Never mind, not twice. I just made it up a second time. Now twice.
Now,
Well, I guess
stop it.
I guess we haven't seen your tooth. We have. There's no tooth to see.
I already read that joke.
When?
It can be noted that Ms. White slanders herself more often than any of you people could ever attempt.
You'd be surprised.
All right.
Does self-slander count on the slander count?
Where is the center count?
Over there. I found
Oh.
it.
Is that daily?
Yeah, I think it was that.
Oh, yeah.
Okay. So, actually, this question is about a ladder and your worst nightmare. By the way, if you really want to know how to set up a ladder the safest way, have I described this to you guys before? Ever? So the ladder is leaning. If you stand at the base of the ladder and reach straight forward, then that you should touch the ladder. That is like the ideal angle. And it's easier to measure than, 73 degrees or whatever it is. So anyway, I did not apparently in this problem decide on my angle very carefully because it is standing up against the vertical wall. If the foot of the ladder is pulled away, now see, that would be something my dog would do. Okay?
I love how it's.
Run right into the bottom of the ladder while I'm standing on it. Things like that have happened for sure.
Really that bad?
Oh, he's awful. Anyway, so the foot of the ladder is getting pulled away. I'm going to make a little arrow there at a rate of 0.74 meters per second.
Minutes per second.
Right? How fast?
That's pretty fast.
How fast is the top of the ladder coming down the wall? And we are going to calculate that at the instant it is 3 meters above the ground. Okay? So, so we need to decide on some variables.
So I'm gonna look at a.
Are we using with that?
Yes, it's falling away. It's like slipping down the. If Biscuit
We need to draw two triangles.
ran into it that way, the ladder would fall down, right? Like straight up against that wall.
It's not like falling down. I've never seen it like slowly fall down.
So we have side angle side.
Correct. Most accidents would happen because you're too steep.
I'm doing Pythagorean.
Although, like, depending on the surface that you're putting the ladder in, it might slip out. Like, I have concrete patio around where I've had to put the ladder up to, like, change a light bulb and stuff.
You ever tried to-
And this actually is a real fear right here, even if I have Biscuit locked up in the house while I do it. So, I need some variables. I think I would like to call this L for the ladder.
You can call the,
You have to like.
Good. So actually that always equals 4. And you said, but Miss White, you said I couldn't plug anything in. Well, is that changing at all? No, the ladder is 4 meters long. And whether it falls or blows away, it's still going to be 4 meters long.
Still using Pythagorean theorem.
Ah, yes. And I think I'm going to call this height. And if I call that height, what would I call this? Base? Okay, gotcha. I like it. So give me an equation based on these measurements.
L squared equals B squared plus H squared.
L squared equals H squared plus B squared, or whatever he said.
Wait. No.
But I know what? I know that my ladder is 4, and it's not going to change. So I can actually go ahead. I can go ahead and make a fool of myself. 16 equals H squared plus B squared. That's always fun. Because, do you want 3 variables?
No.
Or is 2 variables quite enough? Yes.
It's quite enough.
Can you take side of here at 3 meters?
Hold on.
Use that to find tangent.
Hold on. That is what we're going to do to find the angle changing. But right now, I don't want anything to do with angles.
Oh, it looks so weird with B. It's like B, 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 T.
Yeah, it's not a constant rate.
So,
Or this.
y'all listen, this is really good. Do I want to use trig right here? Not for this problem. Because all I'm dealing with are the lengths of the sides of the triangle. In a minute, though, we're going to do the angle, and yes, that's what we would do. Okay? So what do we do now?
Negative B equals H squared minus 16.
Well, I know, you do not have to rearrange it, but you can. It's totally fine.
So I can make it.
And then you would take the derivative. The derivative of 16 is 0, so is his. Equals
2H times DH over DT.
2h times h dh over dt, very good, plus
dB over dt.
dB over dt.
I looked at this one. I guess it's
So what are we, okay, first off, what are we trying to find?
Relationship between those two.
How fast is the top of the ladder coming down the wall? So I am trying to find dH dt. What am I given? Well, first off, L we know, but I already plugged that in because it doesn't change.
You know dB, the 0.74.
That's the length of the ladder.
Ladder squared, 4 meters.
Where did it go?
Oh,
Derivative of 16 is 0. dH dt, no wait, dB dt, sorry, dB dt is 0.74 meters per second. And by the way, this is how my brother-in-law broke his ankle into about 18 different pieces. Yeah. This actually happened. Right. And then we could put his weight in there and do the amount of newtons, the amount of force that was put on his little ankle.
Do we have to use Pythagorean theorem to find E at that point?
Yeah.
Ah, very good. What do I not know? I don't know B. Now, I know H because it's saying, well, we have, if I know that the height is 3, and I know that the ladder is 4, then what will be
Square root of
B? Square root of
7.
7. Very good. Right? 16 minus 9? Yes.
Yeah.
Square root of 7. So when L equals 4 and H equals 3, then B will equal square root of 7. Right? Pythagorean theorem. So actually, I can just start plugging in. 0 equals 2 times 3
It really is nice to rewrite it, because then the 2's can stop.
times dH dt plus, no, that's dB dt. Right. Yeah. Actually, no, wait. No, the dB dt is going to be the 0.74. Yeah, so this will be 2 times B, square root of 7,
you estimate square root of 7 and put it back.
and dH dt, I'm sorry, dB dt is 0.74.
0.6
Okay.
Would it be
So this is our mess. Now I will say this. Earlier, Henry wrote his equation.
Square root of 7 times this.
Harry, sorry. Sorry.
I wrote my equation differently.
Correct. Well, that means that your variable would probably be almost isolated.
Yeah.
So that's actually worth it to do sometimes.
Yeah, and then going off that equation, I got negative B dt over H.
But whichever way you fill that out, you will end up getting negative square root of 7 times 0.74
over 3.
and dividing by 3. Notice I didn't have a 2 and a 2 because those would cancel out. But you ended up doing the same thing. And that is going to be something horrible.
negative 0.5?
Negative 0.653. So it's
That is what I got.
It's going down at 0.653 meters per second.
That's pretty fast.
So actually, to be honest with you, it says how fast is the top of the ladder coming down the wall. So do I need the negative?
No, you don't.
No, you don't.
It's going
Right. But sometimes it is important to know what direction something is moving in, but we knew it was moving down, and it just asked us how fast. So we didn't actually need the negative there, but in some contexts you would need positive
Physics.
or negative. Yeah, exactly.
Is 2 meters like 7 feet tall?
About?
It's more like 6.5.
Yeah.
Oh, so it's like 10 height. Right?
What?
Isn't it 6
How tall are you?
Like 6'1".
Oh, okay.
Ace is 6'5".
Okay, so it's like ace height.
I do not.
So it's like 1/4 ace per second.
It's like 6'4", 6'5".
Yeah, that makes sense. Suppose you do a third of me per second.
Look, they're twins today too.
Yeah, that's a third of me per second.
Hey.
Pretty fast.
Yes. Okay, now,
That's really
and really, this is kind of like, just to be truthful, if I'm standing on this ladder, I do not care what the angle is moving at, the rate of change of the angle. At that point, I'm, screaming. But again, if you're doing the rate of change of an angle of elevation of something or an angle of depression, you would have some sort of right triangle to work with, and you're trying to find that angle. So, what angle am I looking for? In other words, it is the change in the angle between the ladder and the ground. So I'm going to call that theta.
Angle Y. It's asking about Y.
No, y is the height.
Oh, by the way, yes.
I would say angle Y. That's
Y is 2 meters. I'm going to say that that's a vertical distance. So this is, well, I'm not going to plug that in. I'm going to call that Y instead of H for them.
sine law.
What?
I'm using sine law.
You are?
That's the way to do it? Would you use cosine?
Yeah, just use sine.
Okay.
Always use sine.
I mean, you would just take sine.
Now, why would I use sine instead of cosine?
Because y is
Shorter. You know Y and you know the hypotenuse.
Because I know
y.
the y, or the
Well,
opposite.
you could know.
I mean, yes, yeah, it would be a little convoluted. The best thing to do here would be the sine of theta is equal to y over 4, correct?
Yep.
And by the way, that's really just the same thing as 1/4 y. Don't start thinking, oh, we got to do a quotient rule. No, that's just a constant.
You could.
So now we are going to do the derivative. What's the derivative of sine?
cosine.
Cosine of theta.
Actually,
Cosine of theta is,
1/4 dy over
I'm sorry, cosine of theta times
d theta over dt.
d theta over dt. And if you don't put that, you're going to go, what the what? Because that's actually what the question's asking for. So, equals just
1/4.
1/4 dy dt. Now,
dy dt is the same as an
it says in the above problem,
Yeah.
so therefore we're going to go back up to the top where it says it is coming down the wall at a constant rate of 0.74 meters per second. So I'm going to put 0.74 right there. This is 1/4. I'm trying to find d theta dt. And what is
But y is the height. So
what
when-
is the cosine of theta? Oh, it turns out I do need that.
Why are you using
Sorry?
Why are you using 0.74?
Yeah,
Frick.
it should be negative 0.653.
No,
That's the base. That's
Oh, beg your pardon.
Oh yeah, you should be using it.
Oh, yeah.
so.
I'm sorry. Thank you. 0.653. Okay.
Shouldn't it be
Wait a minute,
negative
that's not right either.
0.653?
That's at 3 meters.
This way.
0.653 is at 3 meters, so you need to do another
Oh,
problem
it
first.
sure is.
Yeah, that's true.
You know what? Y'all are making awesome points, and you know what? We should have done cosine.
We can just do another problem of the one above it for to find that number.
Oh, but watch this. If we do, sorry to everyone involved. If we do the cosine of theta equals b over 4,
You have to get signed.
Then you get change in B.
negative sine theta d theta dt equals 1/4 dB dt, and I know dB dt is 0.74. So this will be 0.74
Sine of theta.
and negative, okay, sine of theta is just going to be what over what? Y over 4, and I know what y is. What is y?
2.
2.
So it's 1/2.
So negative 2 over 4 d theta dt. So, yes, that's negative 1/2. So all I need to do is find 2 times that. So 2 times 1/4 times 0.74.
Yeah, negative 0.37. And that would be degrees per.
Nope,
Not degrees.
it would not be degrees.
It would be radians.
It's a very good. That is a very good point you just made. This. Oh, I'm sorry. This is the rate of change of theta over time for this problem, and that is going to be radians per. What was our time? All our time was in seconds. Okay.
Because you used to use it.
Yeah.
Actually going to be radians per second. Now, that is why we do things in radians. That's the whole, honestly, it's calculations like this that are the whole reason we do things in radians, because that is what you get straight up when you do the other math involved and not degrees. So yeah, what were you going to say?
Why is our negative sine theta turned into negative 2 over 4?
Also, wouldn't it be positive?
Shouldn't it be-
assuming it's falling down?
Shouldn't it be,
It's just
Yeah, it should be
how fast
positive and it
it's
should be
changing.
1 over 4, right?
The above.
No, it
How
says,
fast it's coming down the wall. This one just
right,
says
it
how fast
says
it's changing.
when y is equal to 2, the sine
Yes.
of theta would be 2 over 4. And technically, why did I put negative? Well, because the derivative of cosine is negative sine.
But the next number should be positive because it's going because well,
No, because it's only
That
actually
angle
for-
is approaching 0 because it's collapsing. So it's actually decreasing.
yeah.
It doesn't
So
ask for how fast the angle is decreasing. It asks for
very
how fast it's
good.
changing.
How fast is it changing? Then yes,
Whereas
that
the
would we can ignore positive and negative because it is changing at that rate. Now you and I know that it's decreasing at that rate, but yes, the way it's stated.
Think of it in
Totally
physics
fine.
terms.
Yeah.
The first one is asking for the scalar value. The second one's asking for the vector value.
Yep.
Oh no.
Oh, by the way, I'm not going to get to the multiple rates of change, but you do not have a problem like that today. Here they are.
Is it not Delta Math?
Today's assignment is not Delta Math.
No.
Seriously?
Trying to grade this. Delta Math is awesome. You don't even have to
Wait,
grade
I'm
it.
never gonna do it. I'm never gonna learn it. I'm gonna go back to my.
Not good related rates problems on Delta Math. I wasn't.
Yeah, no.
What?
Paper doesn't translate to my brain. I might use like a pen paper.
I can only see pixels.
Y'all are so funny. I'm really glad that you like Delta Math.
I love Delta. Like Delta Math is how.
It makes our lives so
It
much
is an
easier.
unlimited amount of examples for you to experiment with, is it not?
It also tells you what you're
Now I'm not like
I still think
I'm
Delta.
not
I think so.
I'm
John.
not doing it.
John, ST Math, that's where it's at.
Truly,
Not an ST Math.
by the way, the reason I chose specific related rates problems, all of 4 of them, correct, is because these are the quintessential related rates problems that you see over and over again on exams, both the IB and the AP exams. There's always something like this on those exams. And it's sphere, by the way, volume is 4/3 power cubed. Y'all remember that? Ladder, so that's going to be a right triangle. Oh, 3 is a cone, again, very similar to our first example. And number 4 is something's going due west and due north, so their distance would form a right triangle. So really it's like the ladder problem.
And surface area of a sphere is derivative of its volume.
We don't need surface area, I don't think. No, volume. We need volume.
Yeah, we need volume. I'm just reading.
Oh, you're saying that is
Yeah.
the derivative? Yes, it is, sir. Yes, sir, it is. And by the way,
You can use that in higher dimensions.
I'm going to show you in calculus why the formula for the volume is 4/3 power cubed.
Because
that-
it's the
we have to
integral of
integrate,
surface area.
So we did all these calculations about, in order to find the rate of change of the angle with respect to time, and it is just automatically gradient. You just kind of have to know that when when we're dealing with an angle, and we ended up with the rate of change of the angle over time, it always ends up getting, it's automatically gradient.
I'm scared of already.
It also says how fast. And so, how fast did I drive to school today? 40 miles an hour? Or is it, so when I go home, do I drive negative 40 miles an hour? No, I just drive 40 miles an hour in a different direction, which is similar to what you discussed in physics as well.
None of the rest of the things that I've never seen people put in this one. No, I don't want to.
Correct. The 5 squared. So I did 2 divided by.
Or you can know if you were there for physics, I would have.
Obviously.
Yeah, yes, it's not. But did you have to pay attention to like the little details? She's outlining the important details right there. So this is implicit differentiation. However, I forgot to stop my recording.